Hi. If you've been in the drone industry for a while, one of the things you must have come across is GCPs, or also known as ground control points. But what exactly are GCPs? Why do you need them? And how many GCPs do you need? We'll answer all of these questions in this video. Hey everyone, I'm Varun from Hammer Missions, and in this video, what I want to do is I want to talk a little bit about GCPs, ground control points, and I want to explain why they're important and also walk you through how to use GCPs with Hammer Missions, an end-to-end process. Right, so before we jump straight into it, let's just talk a little bit about GCPs. So GCPs essentially, or ground control points, are a method to improve accuracy in drone maps and models. And the way you do that is by placing these markers on the ground that have a known position or a known coordinate that is uploaded alongside your drone data when it's processed into a map or model. And that information of known points is actually used to improve the accuracy of the output map or model. Now, you might ask the question, why do you even need GCPs? You need GCPs because if you think about it, drone GPS by default has error, so it's not accurate. It's got error which could be anywhere from 1 meters up to 2 meters. And so when you're taking photos from a drone, all of the geotags in the images from the drone, they're actually not where they are saying they're supposed to be. And so to correct for that, you need a mechanism where you're able to actually get the photos or the output drone map or model to be where you want it to be. And one way to do that is by essentially having some known coordinates in those images that you can then rely on to essentially process your map or model. If you want to really think about it, you can actually think that this is similar to if your map was somewhat of a poster that you were trying to pin on a board in an exactly flat way and make sure there were no sort of errors in terms of getting that map posted on a board. And then these GCPs are like a bit like pins that you would put in the right places to make sure that your map or model is aligned with that board exactly. So, right, without any further ado, what I'm going to do is I'm going to get into the GCP workflow in Hammer, and then also show you how you would typically place your GCPs and how you would try to aim for the best accuracy possible. Right, let's jump right straight into it. Right, so what you see on my screen now is essentially Hammer Hub, and we're going to be using today Hammer Hub to process a data set alongside GCPs and understand how we can make that data set more accurate with respect to aligning it with base maps and the real world. So, okay, so what you would normally do is you would go and navigate to hub.hammermissions.com. And then you would essentially go into the data analysis tab. Once you're there, you can essentially create a new project. So I'm going to go ahead and create a new project, and I'm going to give it a name. So let's say I'm going to call this one something along the lines of maybe GCP demo. So let's go for GCP demo. And we're going to sort of like go and give it a whatever, depending on what the site is, we're going to give it a type. I'm going to call this one, I think for this particular one, we're going to be looking at some of a wooded area forest that's going to be mapped. So I'm going to mark other. I'm going to give it a description. So just say a GCP project with CSV file. And if I have a mission file I can associate with, I can essentially add a mission file over here. I'm going to use faster uploads. And then I'm going to essentially continue with respect to processing the data sets. Right, so now I'm going to essentially upload my images. So I'm going to essentially click on this button over here and select all of my images. So I've got all of these different images that I want to upload. So essentially what I'm going to do is I'm going to essentially go in and select all of these images, and I'm going to press open. And so essentially, Hammer Hub will go through all of the different images on the device and essentially add them to the project. So it just gives me a preview of all of the files, so I can check that I've got all 187 projects, and I'm going to hit continue, and then create projects. So I'm going to let that upload, and I'll see you right after the upload is completed. Right, okay, so we've now got our project uploaded, and as you can tell, this was essentially a mapping mission that was run on this particular wooded area. And there were certain images which essentially had GCPs or markers on the ground in them. So this will become more apparent once we start the marking workflow. But essentially, there are some images which have markers in them, and our goal here is to be able to upload those images alongside their known coordinates to be able to create a map. So what we're going to do from here is that you can obviously tell that this particular data set is not processed at the moment. So to be able to process that, we're going to click on the process button over here. So we go ahead, we click on the process button, and then we have the menu to choose our desired outcome. So in this particular one, I want to create both a 2D map and a 3D model. So I'm going to choose that option. And I want to use ground control points. So I'm going to click on the use ground control points option, and I'm going to click continue. Now at this point, we're going to have Hammer asking us if we can import the GPS locations. So these are the locations that I talked about earlier. So what's going to happen is when you put these markers down in the field and you essentially measure their known coordinates using a base station, you'll get a CSV file that has essentially all of those different coordinates with you. Now you might be using a base station, or you might be using some other methods, for example, arrow points or something similar to be able to get those coordinates, but you would end up with either a TXT file or a CSV file with all of the GCP names and their known positions. And that's what you need to upload over here. So we're going to go ahead and click on import GPS locations. So once I click on that, it's going to bring up my file directory, and then I'm going to go for GCP coordinates file over here. And essentially, and just to show you what this file actually looks like, let me just bring that up on the screen very quickly. Right, so I've just brought up the GCP file, and this is what that looks like. So you can probably tell it's a very short file. And just to sort of like explain what this file is and what these numbers mean, because you might have come across this file and may not really understand what was included in there. So the first line of the file over here is actually telling us the coordinate system. So EPSG 32613 is the coordinate system in which the GCPs have been located or have been measured. So that's important. And then if you think about these next 5 lines in the CSV file or the TXT file, they have a particular format. So what they're telling us is that the first column on every line is essentially the name of the GCP that was used. So essentially GCP1, GCP2, there was 5 GCPs that were used in this project. So there were 5 different markers put on the ground and 5 different positions were measured. And then if you think about these numbers here, so there are 3 numbers per line and they indicate a coordinate. So this is the XYZ position, or like the latitude, longitude, and altitude of that particular GCP. And obviously they don't look like latitude, longitude, and altitudes, you might sort of say, and that's true because the coordinate system is EPSG 32613. It's not the sort of coordinate system that you typically come across with Google Maps. So it's not the WGS 84 coordinate system. It's the EPSG 32613. And all of these different coordinate systems actually have a way to sort of like convert between one another. So all you need to know is that if you see 3 numbers in there, and if you don't really understand those numbers, it's okay, because as long as you know the coordinate system in which they're in, then you're able to actually use them for your processing. So once again, you've got the GCP name and you've got the position of that GCP, the latitude, longitude, and the altitude. Now, sometimes you might have longitude, latitude, and altitude as opposed to latitude, longitude. Like the latitude and longitude might be switched. So it's important for you to sort of make sure that you're actually looking at the data in the right way. Okay, so once you have the GCP file and you understand the format, what you need to do is you need to upload this file into Hammer Hub along with the data. So I'm going to go back to Hammer Hub and I'm going to show you what the workflow looks like from there on. Right, and now we're back at Hammer Hub, and as we recall what we were doing, we were choosing the GCP locations file. So I'm going to click on that, and it's going to bring up the GCP file that we just looked at, and I'm going to press open, and that's going to get uploaded. Then I need to add the camera that was used to actually capture this data set. This was a Phantom 4 Pro, so I'm just going to add that. Now, GCP coordinate system. Now, this is really important. As I mentioned just a minute ago, this is basically the coordinate system that was in the file. So if I bring up the file again, that's the 3216 coordinate system. So I'm going to go in and punch in EPSG 3216. And then I'm going to find a list item. I'm going to select that. Altitude units. So this particular one was done in feet. So I'm going to go for feet. File format. So if I bring up the file format again, if you look at this file, you'll see that it follows this particular format where it's got the GCP name. That's the GCP name on the first column. It's got the latitude, longitude, and then altitude. That's the file format. So I'm going to go for that. And I'm also going to then choose, or in fact, I think it might be longitude, latitude. So I'm going to select longitude, latitude. Value separator. So obviously there's only space between all of these values. There's no commas between. So I just need to specify that's a space. And there's the option to ignore the first line. So because the first line doesn't actually have any useful information apart from the coordinate system, I'm going to ignore the first line. So I'm going to go in and punch in, ignore the first line. So let's see what happens. Right, okay. So we have progressed to the next stage. And what you'll notice is that we've now been shown the map with all of the blue markers representing where the GCPs are. So there's 5 GCPs in this project. And we also have a little footprint of the drone showing us which particular GCP marker we're now looking at. So if you look at the top over here, Hammer Hub is asking us to zoom into the GCP on the image on the right. That's this image over here. And then press the spacebar key. If no GCP is found, skip to the next image. There's a little video that helps us understand that. So it's particular image, because the drone is actually in this position and looking forward, the GCP is located actually somewhere here. And so I can zoom in over here and I can see the GCP's outline over here. And I can essentially just go ahead and press the spacebar to be able to mark that GCP. So that's been marked. And then we've got another GCP over here that's been already found. Then I can basically go in and press my spacebar to confirm the GCP. Now we're looking at this image over here. So if there was a GCP in this image, it should really be somewhere around here, but it doesn't seem like there's a GCP over here. So I'm actually going to just skip to the next image. No, actually, no, forgive me. There is a GCP right here. So I'm going to press this button over here and then mark the GCP. So, and if I go back again to the same area, there's a GCP here, so I'm going to mark here. So what we're doing at the moment is we're marking the pixel locations of those GCPs, because if you think about it, what you want to do is you want to not just upload the GCP's known locations in the real world. You need to tell the software where the pixel locations of those GCPs in the images are. And that's what helps the software align the map or the model to the real world, because you're essentially giving it not just the locations, real world locations, but you're also giving it the pixel coordinates of where the GCPs are. So now we're looking at this image over here, and according to this, there should be a GCP somewhere this quadrant of the image, which is correct. So I'm going to just go in and mark that GCP. Now we're looking at this image, and there should be a GCP number 4 over here on the top left, and that is correct. And GCPs come in all sorts of shapes and forms. So you might find a GCP that is more checkerboard style. You might create your own GCPs. Sometimes people spray the particular area with a particular color so that they can see it in the photos. As long as your GCP is available at the GSD that you want it to be, then that's okay. That's really what you want. You don't need to have a very particular type of GCP, and that's pretty much it. So we've gone ahead and we've marked all the GCPs, and Hammer's asking us to now process the data set. So what I'm going to do is I'm going to go ahead and process. Roughly speaking, you want to mark roughly 3 or more images per GCP to get an accurate map. In terms of where the GCPs are placed on the ground, as I mentioned before, you kind of have to think about the GCPs as being a process where you're trying to pin a map to a board. And so if you were to pin a map, which was sort of like the images that were captured here, sort of like this single grid images, you'd want to pin the corners first, because that helps in pinning it in the right place. And then you might want to put a few GCPs in the center as well. You want even distribution, and you want to make sure that you're using at least 5 GCPs. Depending on the area that you're covering. Of course, if you're covering a larger area, you might need more GCPs. If you're covering a smaller area, maybe you need less GCPs. But generally speaking, you want to cover all the 4 corners of the map of the model, and you want to have even distribution of all the other GCPs in between. So I think what we've done here is that we've gone through the GCP process, and I'm going to hit process. So let's see what happens now. So at this point, what's going on is that Hammer's essentially uploading the GCPs that we've just marked. And we've now sent our 2D map processing request and 3D model processing request with both the GCP coordinates as well as the pixel locations for where those GCPs are. So I'm going to give this some time to process, and I'll see you on the other side once everything's completed. Right. Okay. So we sent our data set for processing, and it was completed in roughly an hour. And what we have here is the processed result. So this is a processed map that was completed, created using our GCPs. So if I was to bring up the images, you'll notice that these are the exact same images that were initially used to create this map. And the beauty of this map is that it's more accurate in terms of its alignment with base reality. So it would typically align better with where the coordinates are in terms of if you were to use this particular map for any survey work or construction work. It would be more accurately aligned with other maps and models, and also maps and models that are further created on a weekly basis, maybe on a monthly basis. The alignment would be much more accurate, and you can get to centimeter level accuracy with respect to the absolute alignment. So that's essentially the nutshell of GCP processing. You can also look at the data not just in 2D but also in 3D. So we've got the 3D data set over here, which is also very much aligned. So if I was to bring up the terrain over here, you will notice that this is aligned now with the terrain model. And you can sort of look at this data set in 3D as well. And so if I was to really go into the data set, I will be able to essentially come back and look at the GCPs that were used. So I'm going to actually make this full screen so that it's easier for us to see. But you'll notice that that's the GCP that was used. It's one of the GCPs that was used to create this data set. And I know there were 5 other GCPs that were used. So I can sort of see there's another GCP over here. Just looks like a white patch. And there's another GCP on site. So roughly about 5 GCPs. And once again, if you look at all of the images, if I was to bring up all the images over here, you will notice that this was the area being captured. There was a GCP that was placed in the middle over here, but there were also GCPs placed in the 4 corners of the map, which is generally a good place, good way to place your GCPs, because you want to make sure that your map is pegged or pinned to the board in the best way possible. And the way to do that is to essentially have 1 GCP per corner of the map and then evenly distributed GCPs in the middle. I'm going to remove the images now and just look at the drone map that was created. So there should be a GCP in this corner over here. So lo and behold, we've got a GCP over here. So that's the one pegging that corner in the right place. And once again, we can look at this both in 2D as well as 3D. So we've got the 2D map over here, which has been processed using GCPs. Some of the things that we are now looking at incorporating is that you'll soon be able to drop a point and measure the GPS location on anywhere on the map. That will be helpful in terms of understanding the true GPS location of any point on the map. And obviously, you've got all the different tools already at your disposal. So if you wanted to kind of measure any part of the output map, you can essentially go in and just draw using our boundary tool to sort of understand, let's say, the length of that particular. Seems like a little pond over here. If you wanted to understand its area, you can essentially use our area tool and then look at the area for that particular pond. And so if you're doing any work that is more survey related and requires high accuracy with respect to the alignment, that can be really useful. One thing to note is that GCPs and measurements are not always correlated. Measurements generally depend a lot more on the GSD side of things, but we made a separate video on that. But all in all, hopefully this video was useful in understanding GCPs a bit more and understanding the end-to-end process and how you can capture the GCPs, upload the GCPs, process them into a map and model, and then utilize that for survey work. One thing I should say at the very end of this video, that not all projects require GCPs. So if your project does not require GCPs and does not require absolute accuracy with respect to base maps or other maps, and you're doing more of inspection work and you still want to process the model, but you don't really need the survey grade accuracy, then you don't really need GCPs. So it's all about sort of using the right tool for the right job. And so if you've got a project that requires GCPs, then you should use GCPs. If you don't, then using just your drone would be sufficient as well. But as always, just knowing about these things and having them in your arsenal for when you might need them is a good way to go about it. Right. Hopefully this video was useful. Feel free to leave your comments in the comments box below. We're always looking forward to seeing what people think. And we'll see you in the next video of the workflow videos.